Here we are, training 3. In this training, we're going to introduce you to regression estimations, as well as how to create tables from regression estimates. So let's come straight with, and we're going to use a data set called training data 3. So let's bring our do file over here. So again, I'm going to start with letting me know what I'm doing, training 3. And I can just copy and paste this real quick. Whoops. And today is the date. Just this knows that which version you're on as you're working. And here we go. Okay, so the first thing I want to do is change the directory to where the files are located. For me, I have training 3 data. Here's the files. They are DTA files. So I copy this. I put that in there, and then I use training data 3 clear. When we clear out everything, we run this. And one thing we're going to note real quick is that this is called data 3 or data 3 data or training 3 data. And now we're good. So here are our variables located here on this side, and we want to be able to estimate regressions. So if we start with just a simple regression, let's suppose we want to look at the relationship between age and income. So I come here, let's maybe call this model 1. And so all I have to do is type regress my dependent variable, which is income, and age. I run this, and here we have our coefficient on beta 1, or our coefficient on age. Here we have our constant, or we call our intercept term, beta naught. We give a coefficient and a standard error, and then it's going to test that against the null hypothesis that it's 0, and that'll be this t-stat and this p-value. It'll also give us a 95% confidence interval around this coefficient, so we're 95% certain that the true population parameter is between these two numbers. We have our observations, we have our r-squared, and all that information here. So that's a basic, simple regression. Now let's suppose we want to do a multivariate regression. And we can add variables. We can do regress income, age, and then we can add a variable like female and married. We run those, and now we are good with a multivariate regression right here with these coefficients. Again, the coefficient, estimated coefficient, the beta hats right here, standard errors, and the default t-statistic. So really quite simple in terms of running multivariates. If we wanted to include a lot of different variables, all we have to do is just keep adding more variables here at the end, and that's not too bad. But let's suppose now that we want to add a variable that incorporates race. So if I want to do here, I can do tab race. Notice that there's 9 different categories for race. So I want to be able to control for this with categorical dummy variables. All right, so the way I can do that is to create, so let's call this create dummy variables for categories of race. Okay, so one way you might be able to do this is you can do gen white equals 0, replace white equals 1 if race is 1, and you can go through that process. I have to do that 9 different times. That's rather tedious. The shortcut way to do that is to do tab race. That's going to tabulate the race. Gen race, what I'll call race G. So this is for a race group. And when I do this and I run this, it's going to tabulate here, but at the very end here, it's going to create 9 different dummy variables for each of these categories. And so if the race is equal to white, then it creates race 1. And now that I have those, to incorporate those into a model, I can just grab these right here. Let's call this model 3. And then I can do race G. Let's start with group 2 and go through group 9. And that means group 1 is the omitted category. So I run this, and now it gives me each of these coefficients on the race. So that's one way going about doing that, but that does require you to create these dummy variables. Another way that might be a little easier. So let's call this dummy variables, or even better is categorical dummy variables. Is the other I can just do is race and or regress, sorry, income, age, female, married, and then rather than include all these different ones, I can do I.race. And this will then do a dummy variable for each of the outcomes for the variable race. So I run that, and notice here, so here was the first one where we did regress race 2 to race 9, and now it's going to run that regression, and it's going to have now these I dots, and these are the exact same coefficients. That's really incredible. That's very helpful. It's a lot quicker to do. Notice that the coefficients on age, female, and married all stay the same. So that's another way in which we can run that type of regression. All right. Another way is, let's suppose that this will show all these different outcomes. Let's suppose we do occupation, where there might be thousands of different outcomes. So that rather than have STATA report us those thousands, I can just say, hey, control for those dummy variables, but then don't show me the results. So I can do income, age, female, married, and then I can do absorb race. And so this will absorb, it'll include a dummy variable for each of the outcomes for race, but it will absorb and it won't show those results. So here we have the absorbing indicators. We have those same coefficients on age, female, and married. So that's another way to go about doing it. A last way is through xtreg, because categorical dummy variables can also be thought of as fixed effects. Right? And so the other thing I can do is I can do xtset, where I'm setting my xt, and let's set that as race. And then I can do xtreg, income, age, female, married, and then fixed effect. By doing xtreg, it's saying, hey, use race as a fixed effect. So I run that, and now I get the same thing. Another way to calculate categorical dummy variables, what we might call fixed effects. So that's, in a sense, 4 different ways to go ahead and doing that. So these are different ways that we can run regressions. All right? And there's a whole lot of many other ways, but these are just, in a sense, the basis of doing so. Well, let's look at objective 2. We want to create tables. So one way to create tables is you can literally just grab these here and copy paste into Excel. That's not the ideal way. One of the ideal ways is we want to be able to use a command called outreg2. Now, outreg2 is not originally loaded into STATA, but you can load it into STATA. And the way you can do that is if you do ssc install outreg2. Okay, I can type it directly here into the command prompt, or I can even come up here to my do file, and I can type it outreg2. Or, oops, sorry, ssc install outreg2. So if I know the name of the do file, ADO file, then I can just put it in right here, and I can run it, and it'll notice it'll check for me, checking to see if you have it. I have it, so it'll run through the data file. Okay, so here it's checked, files already exist, because I have downloaded this before onto my computer. If you're working in a lab, you might have to do this every time. So let's just have that install right there. And the way that this works is after I run a regression, I can do outreg2 using, and let's call it training.xls, not SLSX, but just XLS. And I do standard error bracket. And I'm going to do replace. If this file already exists, then it's going to replace it with this new file. So I'm just doing the outreg2 after this first regression. So I run through, it's going to check, it's going to go through, and after that first regression, if I come up here, I can either check this C directory out, and that'll show me what the table will look like in STATA. Right? So again, it's a single column with our coefficients and our observations in R squared. Or I can even click, I can pull open the folder, and it's right here. So I can open this up, and here it is in Excel format for me to look at. Okay. except there's one small thing I forgot to do is here its output is I need to make sure I actually change the directory. So here my directory is still in the data. So here I'm going to actually, after I load the data, I'm going to change the directory to put it into my output folder. Okay, so here I'm going to delete these two files right there. So here's my output folder. So if I come to my data, it turns out here's where those are. I'm going to delete those. So let's see if this works now. So I'm changing my directory to bring in the data set. I'm changing my directory to the output. And now I run this. It's going to check for outreg2. It's going to get it. And I open up my data set, my output folder, and sure enough, there it is as an Excel file. Okay, here we go, opens up. And here is that table. And this is really quick, click, and easy. I can copy this, paste it, and put it right into my paper. Now, this is one column. Let's create a table that, the next thing that outreg2 can do is I can create a table that each of these different regressions is a different column in my regression. So I just have to come here, and rather than replace, I type append. And so after each of these regressions, I'm going to type append, and now I run this. It's going to run through that whole file, and it's going to create me an Excel spreadsheet. That's a really nice way to present a table, especially when we're looking at several different versions of a specific model. So each of those regressions is going to be a column here. And notice that these regressions here are all supposed to be the same, and sure enough they are. And this is a really nice way to be able to present and create a table that might be used in your paper. So that is our second objective, is to create these tables. Now there is, here we used outreg2. There is another command called STOUT, E-S-T-O-U-T. You can search for that to learn more how to use a STOUT. I'm personally using outreg2, but I know other people really like to use a STOUT. But there you have it for training 3.